Okay, hello class. How are you? So hopefully you all are fine and ready to follow this class. Okay, ready to join this class. Okay. So today we are going to continue our lesson about chapter 3. Okay. The topic is about gravitation. Okay, remember gravitation. In this topic there are three subtopic you need to learn. All right. So this is the first subtopic. It's about uh, gravitation law. Okay. Uh, you are unlucky lah. Okay. Your batch and the previous batch from 4. Uh, you all are unlucky because need to learn this topic too early. Okay. At my batch, at my age before, I learned this when I study at matriculation. Okay, so now you learn this topic in form 4. So just get ready and give you focus. I try to explain you step by step lah. Alright, so at first, what is gravitational force? So this is you already know from the previous lesson. Force that act towards the center of Earth. Okay, gravitational force also known as universal force. Okay, remember that we also call it as universal force, and it exists between any two bodies in universe. Okay, it should be exist in between of two bodies. All right. Okay, let me give you an example. Okay, this one. Okay, have you ever think why does a fallen leaf move towards the ground? Okay, pernahkah you fikirkan kenapa tu daun kan dia akan jatuh ke bawah bukan jatuh ke atas? Okay, so this is the explanation. Both the leaf and the earth here kan we may, refer to the ground. Okay, both the leaf and the earth experience the same gravitational force. Means dua-dua itu ada gravitational force. Okay, alright. Wait. So this causes the leaf and the earth to move towards one another. Okay, as the mass of the earth is very much larger than the mass of the leaf, gravitational force does not have an apparent effect on the earth's movement. As such, we only observe leaf falling to the ground. Okay, actually dia macam ni kan. Wait. So this is the leaf. Okay, falling down to the ground or to the earth. Okay, actually this is earth. Okay, earth or ground. Okay, actually leaf and earth experience the gravitational force, but when we consider the mass, the earth mass is larger than leaf mass of the leaf. Okay, that's why they are pulling towards the ground. Okay, actually leaf also pull the earth and earth pull the leaf. Okay, but the earth is have a larger mass, that's why it can pull the leaf towards the ground. Okay, it's because of the mass. Pernahkah kamu fikir itu ground yang naik pergi atas? Logically lah kan, tidak kan? So anything that yang jatuh fall, dia akan jatuh ke tanah. Tidak pernah benda jatuh naik ke atas. Okay, so this is the example you need to understand. So macam dalam nota tadi, okay, dalam nota tadi, exist between any two bodies in the universe. So lift and earth tadi refer to the two bodies. Okay, refer to the two bodies. This is the lift, this is the earth. So this is the first body, this is the second bodies. Okay, or you can look at this example. It's about earth and moon and sun. Earth and moon, which one is have a larger mass? Of course earth. Okay, of course earth. And the moon is have smaller mass compared to the earth. That's why itu bulan itu dia akan orbit the earth. Okay, let's say wait. Alright, okay, you see these coins. So let's say this gold coins is earth. Okay, and the silver coin is moon. Okay, so the earth have the larger mass. Okay, actually they are, okay, you look at this diagram. Actually they are pulling each other. Okay, earth pull the moon and the moon is pulling the earth. Okay, but the earth have a larger mass, so the pulling force from the earth is more. That's why the moon will attract to the earth. Okay, that's why dia akan orbiting the earth. Okay, dia akan comes nearer to the earth. Okay, because the earth have pulled the moon to the earth. Okay, and then they are orbiting the earth. Dia akan berpusing lah. Okay, same goes to the sun. Okay, let's say this is sun. Okay, the silver coin. Okay, so the sun is the largest star in the universe, in our space, aerospace kan. So why, that's why sun dia akan attract all the planet, Earth, Mars, Jupiter, Neptune, Pluto towards the sun. Okay, then all the planets are orbiting the sun. Okay, because the sun pull all the planets towards sun. Okay, comes nearer to the sun. Okay, hopefully you can understand lah. I try to explain you slowly lah. Okay, you just imagine a body that have larger masses, dia akan tarik the other masses. Actually at first they are pulling each other, but the bodies that have larger masses, dia akan lebih kuat daya tarikan dia. Right, so this is happen in our universe. Okay, alright. Okay, next you need to know how to explain Newton's universal law of gravitation. Previously you already learned about three Newton's law. Okay, the first Newton is about inertia, the second Newton law is about F equal to ma, and the third law is about action and reaction. So this is a new law by our best friend Newton, the people that you hate very much kan, because it stated too much concept. Okay, so now you need to know how to explain Newton universal law of gravitation. Okay, this one. So what is Newton's state? Gravitational force between two bodies, okay, between two bodies is directly proportional to the product of the masses of both bodies. This one yang kita discuss tadi kan. So the larger the mass, so dia punya gravitational force is more. Okay. And the second point is gravitational force is inversely proportional to the square of the distance between the center of two bodies. Okay, so this is new. Okay, Marvin's universal law of gravitation. Okay, actually not Marvin lah, Newton lah. So when mass is larger, gravitational force is increases. Alright, let's say lah we have two people. Okay, we have two people. Let's say okay, this one kan. Pernahkah kamu fikir why people in this earth, kita lah kan, kita bilang kalau two bodies in the universe will attract each other, will pull each other. Tapi kenapa kita tidak? Let's say this one is teacher. This one is Abigail. Kenapa kalau kami dua berdekat kan, jalan sama-sama tapi kami tidak melekat? Why we don't stick together and then move forward? Why don't? Because our mass is too small. Okay, that's why we neglect our mass untuk kita penuhi syarat gravitation law. Okay, kita punya mass ini terlalu kecil, too small to follow the law, so kita neglect. Okay, kita tolak ini. Contoh kita boleh pakai, kita kena ada two bodies that have a larger mass. Okay, let's say Pluto, Mars, Neptune and others lah. Okay, so this is the reason why we at Earth kan, two people didn't stick together when they are meet. Okay, alright, so back to the topic. We discuss the second point here. Gravitational force is inversely proportional to the square of the distance. Okay, this one you need to highlight. To the square means square maksudnya kena kuasa 2. Distance between the center of two bodies. Remember, center of two bodies. Okay, take a look at this example. These are two bodies, the yellow one and the pink one. So to consider the r, okay, r or the distance, you need to take the center of the two bodies. This one, alright, this one. So this is the r. Take from the center, from the first body to the second body. So this is we call as r, or the distance. Okay, alright. Or we can conclude this Newton universal law of gravitation in the form of formula. Okay, this one. Alright, this one. Okay, this one. So we can conclude this as a formula. F is directly proportional to the product of the masses of both bodies. So we have M1 and M2 because masses of both bodies means ada two bodies kan, directly proportional. But while gravitational force is inversely proportional to the square of the distance between the centers of two bodies, means this one, square of the distance. Okay, square of the center of two bodies, r square. And we need to add up, here is the constant G. Okay, G. So the formula is F equal to G multiply with M1 multiply with M2 divide by R square. Okay, you need to remember M is the mass of the first body, M2 is the mass of the second body, and R, this one, you need to alert this one, distance between center of two bodies. So you need to take from the center of the second body to the first body. So this is, we call it as R. Don't forget to square. Okay, so G here, G is gravitational constant. So it's already given in the question or the situation. So the value is 6.67 exponent negative 11 Newton meter square per kilogram square. Alright, so remember the unit for the mass is kilogram. Make sure you need to change to kilogram. If the question give you in gram or milligram or something, you need to change to the kilogram. You need to convert to the SI unit. Same goes to the R. R is distance, so the SI unit is meter. When the question give you in centimeter, you need to change to the meter. Alright, okay, actually this is easy. Later we will discuss about the calculation. Okay, we continue to the last part for today. Effect of mass and distance of two objects on gravitational force. So you need to know about this, the effect of mass and the distance. So means we need to consider the M and the R. What is the effect to the gravitational force? So F is gravitational force. So as you all know, as I told you before, the larger the mass, the larger the gravitational force. So let's see here. Okay, this one. This is a smaller one, kan? And this one is the bigger one. So the larger the mass of the body, the larger the gravitational force. That's why F1, this one is F1, this one is F2. So in these two situations, which one have the larger gravitational force? For sure the F2, right? So F2 is greater than F1 because of the mass. The larger the mass of the bodies, the larger the gravitational force. Alright? So for the second point, okay, it's about the radius or the distance. So here is the first situation. Okay, this is the first situation, this is the second situation. You look at the radius, the distance. Let's say here is 3 meter. So for sure here is much longer than the situation 1. So let's say here is 6 meter. Okay, so we can conclude gravitational force decreases. Okay, F will decreases when the distance between the two bodies are increased. So this is just mathematically lah. Okay, this one, this is the formula, kan? This is the formula. M1, M2, and R square. Mathematically, when R square is increased, okay, wait. When R square is increased, what happened to the gravitational force? Is inversely proportional, right? So R square increase means the gravitational force decreases. But what happened to the mass? What happened to the gravitational force when we increase the mass? Okay, When we increase the mass, the gravitational force also increase, because the relationship is F is directly proportional to the F. Okay, this is just mathematically. Alright, so easy lah. For this small subtopic, still easy to understand. Okay, actually when you look at the textbook, this is just 4 pages, but we took 20 minutes to discuss. Okay, so you need to ready this topic. You need to learn so many concepts, and you need to calculate more question. We need to calculate so many question related to the formula. Okay, so let's check the example, how to calculate, how to use the formula of F equal to G m1 m2n over r squared. How to use this formula. Let's say example 1, calculate the gravitational force. Means you need to find the F between a durian and the earth. Mass of the durian given is 2 kg. Mass of the earth 5.97 exponent 24 kg. And the distance between the center of the durian and the center of the earth is 6.37 exponent 6. So actually it's already give you all the information, m1, m2 and the r. So just substitute to the formula. Okay, this one lah. The value of G is 6.67 exponent negative 11. So this is referred to the G. 2 kg is referred to the mass of the durian. And 5.97 exponent 24 is referred to the mass of the earth. And the distance between the center of the earth and the durian is 9.37 exponent 6. Don't forget to square it. So when you punch your calculator, you will get the answer. So you will get 19.63 Newton. So the unit is Newton. Okay, don't forget. Alright, this is the first question. Easy. We look at the second question. Okay, here a rocket at a launching pad experiences a gravitational force of 4.98 exponent 5 Newton. So this is F. So obviously this question didn't ask us about the gravitational force. Didn't ask us to find the gravitational force, right? So what is the mass of the rocket? Alright. Okay, actually this is a rocket kan. So in physics you need to imagine the situation. Okay. Okay, this is the earth. Okay, let's say like this lah. So what is the mass of the rocket? This one is m1, m2. The question give you what is the distance. Distance at and center of the rocket is, or it gives us. So the r is from the center of the rocket. Oops. So let's say here is the center of the rocket and the center of the earth. So the r is 6.37 exponent 6. The mass of the earth is 5.97 exponent 24. So according to the information given, we have m1, r, and m1 we don't have. We need to find this m1. We have r, we have m squared, and we have already the value of g, because the value of g is constant. Okay, didn't change. So according to the formula, okay, this formula, just substitute the value. So the value of f is 4.98 exponent 5, and then 6.67 exponent negative 11 is g. This one is mass of the earth, me, mass of the earth. M2 is mass of the rocket, mr. Okay, so we need to find this one, and the r is 6.37 exponent 6 square. Okay, the distance between the center of the earth and the rocket. So when you manipulate the formula, then the formula will become like this. Okay, you bring 6.37 to this one. Okay, 4.98 exponent 5 times 6.37 exponent 6 square, and then you will divide with this two value. Okay, that's why here is 6.67 exponent negative 11 times 5.97 exponent 24. And when you punch your calculator, you will get 5.07 exponent for kilogram. So the unit is kilogram because you find the mass of the rocket. So this is easy, still easy, but you need to understand the concept. Okay, let's recall a little bit what we have learned today. So actually you learn about the gravitational force. Okay, so gravitational force, this F, okay, it's depend on the M and the R. Okay, F, the gravitational force is directly proportional to the R. Directly proportional to the M. When M increase, F also increase. Okay, but when we compare to the F with the R, F is actually inversely proportional to the R. When R increase, F will be decreases. Okay, remember this point. So again, this one, when the question asks you explain the Newton's universal law of gravitation, so this is the main point. Okay, like I told you today, F is directly proportional to the M. Remember, the M is product of masses of both bodies, product of masses of two bodies. Okay, you need to mention two bodies. Okay, and the second point is gravitational force is inversely proportional to the distance, not distance only, distance between the center of two bodies. Okay, because we consider the two bodies, so it fulfills the Newton's universal law of gravitation. Okay, like this one. So gravitational force exists between two bodies in the universe. So don't forget the words two bodies. So that's all for today. I will give you tasks and try to answer the questions. Thank you. See you in the next videos. Bye.